Welcome to this seminar on marine equipment communications. The first NEMA 0183 combined electrical and data specification came online in March of 1983. It uses 480 baud, 8 data bits, 1 stop bit, no parity or handshake. NEMA 0183 standard defines electrical signal requirements, data transmission protocol, and specific sentence formats. The standard supports one-way serial data transmission, so one talker and one or more listeners. Data is in printable ASCII format. May include items like time, position, speed, water depth, and so forth. In December of 2023, NEMA 0183 version 4.3 became available. It updates the suite of global navigation satellite system senses for the US, Russia, Europe, China, Japan, and India. You can use the GPS test app to see what's available in the United States. Here's an example of the GPS test app and shows the signals that are available in the United States. The higher the signal to noise ratio, the better. NEMA 0183 high speed is included as an appendix. It increases the speed from 4800 baud to 38.4 kilobaud. Sentence formats are common to both NEMA 0183 and 183 high speed, and 183 high speed is often used for AIS and so forth. Here's the most common NEMA sentence that is specified within the standard so that all talkers and listeners know what to expect. Here are just a few of the common NEMA 0183 sentences that are available, and much of this information is needed for AIS transmissions. NEMA 0183 does not define the physical connector type, so there are a lot of variables to deal with. Here are just two of the many connectors that you may find used on NEMA 0183 devices. Older computers and laptops use the DB9 connector that you see here that was also used for telephone modems. So occasionally you'll find it. Here's one set of pinouts for DB9 RS422 transmit and receive. Aboard sailing vessel Toucan, we use a Raspberry Pi with a serial port running OpenCPN software, and we use our TV set as a monitor. We get AIS receive only from a standard Horizon VHF AIS through a Molex connector. For modern computers with only a USB serial port, you'll need one of these adapters to go from your NEMA signals to the laptop if you want to make them available on the laptop. NEMA 2000 was first released in 2001. The author, as an IEEE member, served on the Early Advisory Committee. NEMA 2000 is often abbreviated N2K, and it is a plug-and-play communication standard for marine sensors and display units. It communicates at 250 kilobaud and allows any sender to talk to a display unit or other compatible devices, and it is compatible with the Controller Area Network or CAN bus. Since NEMA 2000 can have multiple bidirectional talkers, data collisions must be avoided. The current technique uses CSMA-CDA. Carrier sense multiple access is used before the device attempts to transmit. And it first listens to the network to see if the bus is idle. Once transmission is attempted, a message priority is used to resolve conflicts. Here's the example of just some of the many NEMA 2000 sentences that are available, and there are quite a few of them. Early computerized outboards sometimes used a blinking trouble light to indicate a limited number of problems. Here you see early Mercury 115s on my 42 by 10 Trace 1 passenger vessel. Modern outboards use the full CAN bus technology. CAN bus is what your car computer uses to communicate. If you get a check engine light, it means the computer senses a problem, and the mechanic will read the codes through an under-dash connector. You can do some of this yourself with an ODB link and an associated smartphone app. N2K protocol is used to create a network of electronic devices, typically marine instruments. Various instruments that meet the standard can be connected to one central cable known as the backbone. The backbone also powers each instrument and relays data among all instruments on the network. Thus, one display may show many different types of information and allows instruments to work together since they can share data. N2K also specifies the physical layer, unlike NEMA 0183. Here's an example of a connector and the pins within the female connector. Here's an example of a very simple N2K network. You only need power in one place. You need two terminators and a backbone extension cable plus the T connectors. Here's what the NEMA 2000 power drop cable looks like. Here's an example of NEMA 2000 network aboard the Star of Knoxville riverboat. You've got a female terminator, male terminator, and then other items connected all on one single backbone. Some devices can accept NEMA 0183 and NEMA 2000 plus analog signals. This is a float hub vessel data monitor aboard the sailing vessel Toucan, and it has Wi-Fi and cellular data output. More modern chart plotters like the B&G that we used in the Caribbean have Bluetooth interface so you can do your planning on a tablet. Here you see an example of a very short route planned on Aquamap and then transmitted to the BNG Zeus chart plotter with Bluetooth. With this technique, you don't have to worry about SD card handling. Both Bluetooth and Wi-Fi are wireless technologies. Bluetooth connects two or more devices directly over short distances using low power and data transfer, typically used for a cell phone to a car display, unless you're using the USB adapter. Bluetooth runs at 3 megabits and typically runs about 33 feet. Wi-Fi, on the other hand, connects a device to a local network or the internet over a much longer distance. It can have speeds up to 10 gigabytes and indoors 150 feet or outdoors 300 feet. NEMA OneNet was released in 2020, and the first devices became available in 2022. OneNet is a third-generation networking standard, and it's based on Ethernet protocol, so it can handle up to 60 devices and go up to 10 gigabytes speed. Here's an example OneNet. You see different sensors connected and also a router in the lower right. NEMA OneNet is based on the Internet Protocol version 6 and uses Ethernet like you use to connect your home computer to a modem or device. Here you see a male connector and also a splitter or router. Ethernet speeds are dependent on cable type. Cat 5 and 6 can go up to 1 gigabyte, and 6, 7, and 8 can go up to 10. But these speeds may be limited by a router, but any of these are fast enough for recreational vessels, including radar. Here's an example of a male Ethernet connector, and you can make your own, but it is definitely not advised. It's much better to buy pre-made cables that you know will comply to the standard. TCP/IP is a suite of communications protocols for the Internet and Ethernet. It allows devices to exchange data. Internet protocol handles addressing and routing, and transmission protocols ensures reliable ordered data delivery. IP addresses are a unique identifier used to assign every device connected on a computer a digital address. It allows devices to communicate with each other and assures data is sent to the correct destination. It's much like a mailing address for physical mail. Here's an example IP address, and the 192.168.1 is a network address, and 10 is the device within the network. You can enhance your privacy using a virtual private network or proxy server, which routes traffic through an intermediate server. Here you see the progress of vessel equipment communications. 183 was released in 1983. 1998, Iridium Offshore became available. 2001, NEMA 2000. 2020, NEMA OneNet. And in 2022, Starlink became available for marine use. Orca Marine Navigation is an app that you might want to look at and also has physical devices. Here you see a marinized tablet that is available through Orca. Here you see the Orca Core 2 that has a built-in compass and a GPS and feeds instrument panels on your phone or tablet. It has a 9-axis internal motion sensor and can sometimes yield a GPS accuracy of 5 feet. For inland boaters, the Orca app has 2 very important capabilities. If you do automatic routing, it follows the sailing line, and also charts are updated every 2 weeks. A chart download subscription costs $65 a year, but as long as you have internet connections, you don't need to download charts. Large vessels use something called ECDIS, Electronic Chart Display and Information System, and these are much more complex than the chart plotters that we typically use, but their standards development helps us with our applications. So after looking at all of this, what do you actually need? If you only have older equipment with NEMA 0183, this may be sufficient. NEMA 2000 is bidirectional and can support many more devices. You may need an adapter like the one shown here to connect older devices to the NEMA network. If you have radar and want to handle it, you probably need NEMA OneNet. Coastie says, thanks for watching and safe boating. And remember, America's Boating Club Knoxville has marine education from basic boating through offshore, and we have a new inland boating course coming in February of 26. And don't forget, educated boating is more enjoyable boating.